topic that we're going to cover in this asynchronous lecture is on presenting data. So, how do you present data is very important um, for when you're presenting your results to other people and other scientists and other engineers. So, um, if you have data that follows a linear trend, it makes the most sense to plot that data on a rectangular format. So both the x-axis or the ordinate axis and the y-axis are both defined on a linear scale. All right, so that's shown here. All right, for a exponential or logarithmic relationship, like that's shown here, you would want to use one of your scales, either the x or the y scale, would need to be logarithmic, while the other would be uh, uh, linear. Right? Now, if you have a polynomial relationship, it makes most sense to plot a power using both the x and the y be logarithmic. Use logarithmic scaling. All right. So just keep that in mind when you're presenting data and you're looking at data. Very important to check are the scales of that data, are they both linear? Is one linear and the other log, or are both log? And I'll tell you a little bit about the presumed relationship between your independent variable on the x-axis and your dependent variable on the y-axis. If you're presenting raw numbers, a very important thing in your reports is to consider what are the number of significant digits that are sufficient to report. All right. So when you so typically the number of significant digits should be a function of the level of confidence in the measurement and the relevance that extra digit provides. So for example, all non-zero digits, all right, in a number, right, that are presented in a paper are significant. All leading zeros are significant. Zeros positioned between non-zero digits are significant. All trailing zeros, when situated either to the right side of a decimal point, are significant. And then for exact counts, zeros are significant. Okay, so if we to avoid confusion with all this stuff, the best way to avoid confusion in terms of significant digits is to use scientific notation whenever possible to avoid any sort of miscommunication over significant digits. So either you can use, for example, two significant digits. You can either write it as being 0.0042, or you can just write 4.2 times 10 to the minus 3. Very easy to understand how many significant digits there are there. All right. For rounding using the same rules that you typically do. If you have another significant digit that you're not super confident in, so let's say, for example, if you had looked at this 0.0042 number and you had a reading that was maybe you had an extra digit and you only think two significant digits are necessary and you had a 4 here, you would round down to 0.0042. Okay, so pretty simple, nothing new there. All right, so in terms of numerical operations, you should follow these following rules. So if you add or subtract, all right, the number of digits after the decimal in the result should be less than or equal to the number of digits in any data point used. All right. All other operations, the number of least significant digits of the data points used in that argument should be used. So if you multiply two numbers, one has 4 significant digits, the other has 2, you would use 2. All right. All right. You don't need to worry about exact numbers and constants when you're using the appropriate number of significant figures. So if you multiply something by pi, you don't worry about the significant figures there. And then you do not need to round intermediate calculations to determine the final answer. So do all the calculations with all the significant digits, and then at the very end, look back at the numbers you used and then determine what would be an appropriate amount of significant digits that you could use to determine your answer. Right? So, so, when you're looking at different devices like analog devices, digital readouts, tables, and computer-based data acquisition, they have different rules for significant figures. So analog devices, typically you take every significant digit plus up to one extra interpolated digit. Digital readout, you just record all the available digits, tables. If you have a value that you're reading between two values in a table, you'd use linear interpolation, but use the same number of significant digits as used in the table for reporting the number. All right, so you use the exact number in your calculations. And then the last thing is computer-based data acquisition. Just carry out as many digits as possible and round the final answer to the appropriate number of digits that you have. All right. So, all right, that concludes this asynchronous lecture. And if you have any questions, feel free to reach out to me via email.